Good evening, guys. This is Daniel AG again. With this particular video, I'm going to talk about SQL Server page internals. I'm getting a lot of requests from students to have they want to have a better knowledge on how exactly data is actually stored internally. So what I'm going to do is that I don't want to use this particular spreadsheet. So normally I don't use any fancy slideshows. I only use Excel and SQL Server Management Studio, which is more productive in terms of teaching and learning. So well, first of all, let's go through some jargons here. So we already know what a data record is. Data records are nothing but data stored in a raw format in SQL Server, specifically SQL Server data files. Now, a row can be a record from a table, an index information, index data, or metadata. Database boot page is there, boot information is there, ghost record, forward records, LOB records, or version records. All these can be stored as a row in SQL Server. Now, when we talk about storing rows in SQL Server, we always use a technique called a format called as fixed var format. The name came from the fact that that row consists of both variable and fixed data, so that's why it's called as a fixed var format, fixed variable format. Now, we already know that a SQL Server database can contain one or more data file. Extension of the data file can be either MDF or NDF file. Now, each data file can be subdivided into multiple 8 kilobyte pages. Now, as I said, these pages can contain index data or table data, metadata, ghost record, and all those kind of information can be stored. But a single 8 kilobyte page can be divided into multiple 8 kilobyte data pages. Now, let's concentrate more on how SQL Engine store data in these 8 kilobyte pages. So I'm going to open another worksheet here. All right, so this is a representation of 8 kilobyte page. I'm not going to call this 8 kilobyte frequently. I'm going to call this one as data page. Okay, that's more convenient for you and me. So a data page consists of, well, the actual size, every time we call it as 8 kilobyte page, but in fact the actual size of a data page is 8192 bytes. Out of that 8192 bytes, it's actually divided into two categories. The first category is header. Header consists of 96 bytes. Now, what information is stored in the header part? Header contains all the metadata for an individual 8 kilobyte page. So metadata corresponding to an 8 kilobyte page is what's stored in the header part of a data page. We will see how you can read data direct, or how you can see what is there in each 8 kilobyte or data page. We'll be seeing that through some DBCC statement, probably 5-10 minutes from now. And the second area is called as the body of data page, which is 8096 bytes. Now, the body of data page also contains another type of information, is what we call as record offset array. Now, when you are when SQL Engine insert a record into data page, well, that record is going to be residing in the body of data page. But in addition to that, there is going to be an entry made into record offset array. Each element in a record offset array is what we call as a page slot. Now, each page slot size is going to be 2 bytes. So it is a single data page consists of an area called as record offset array. So this array consists of multiple 2 byte information, which is what each 2 byte is what we call as a page slot. Now, what is the significance of this 2 byte information stored in each of those page slot? So when a record gets inserted into body of data page, the starting position of that record in terms of byte is going to be stored in that page slot. For example, when SQL Engine insert the first record into this data page, well, that record is going to be inserted in the body, but at the same time, there is going to be a value inserted into the page, the rightmost page slot clearly explains, okay, from which byte that particular record is going to start. That record just got inserted where it is, what is the starting position in terms of bytes in the body of that data page. Now the page slot always going to start with 0. The first slot number, the first page slot number is going to be 0, not 1. It's always going to start from 0. Now the order of the record, the physical order of the record, in turn, every time when SQL Engine insert a record into the body of data page, don't think that it is always going to be in a particular order. For example, the 54th record inserted might be the first record in that body of the data page, but the first record get inserted might be the 34th record. So the actual order of record, the way the record is stored in the body of a data page is not going to be in a particular sequence or a particular order, but the page slots are always going to be whatever the physical order in which records are kept in that particular table. Okay, if we have a particular order in which record need to be stored in a table, then the slots are going to be in that same exact order, not the actual record. We'll be seeing that very shortly. All right. Now, the fully qualified name of a record, I mean, if you want to address when SQL Engine looking for a particular record in a particular table, in a particular database, well, the fully qualified name is also what we call as record pointer. It's going to be file ID colon page ID colon slot number. File ID means the unique ID of a particular data file in that particular database. Each data file is having a unique file ID. And so the file ID colon, then each data file consists of multiple data pages. So each data page is having its own page ID. So that is what the second part is. Now each page is having multiple slot number. So each slot number is pinpointly say where that particular record is going to start. So a fully qualified pointer for a record in a particular table in a particular database is going to be file ID colon page ID colon slot number. Now so that is about some general information about 8 kilobyte page. Now let's go to my next worksheet here. Now let's talk about the records, right? So the slot number contains a pointer pointing to the start of each record in that particular data page. Now, how exactly records are stored in that data page? Now, let's assume that I have a table consists of 3 columns. Two columns are let's say integer and car. Another column is var car. Now, don't think that I have 3 columns, so only 3 column where those 3 column values what going to be there in each record. That is not true. In addition to those 3 column values, there is going to be a bunch of additional metadata stored along with each record in that table. So that's what we are going to investigate. Okay, what are the additional metadata going to be stored in each record? All right. So this is how typically SQL Engine is going to store a record in data page, 8 kilobyte data page. So when a record get inserted, the first 2 bytes of that particular record indicates what type of record that one is. Now, when I say what kind of record, a record can be different category. A record can be a record from a table, a record from an index, or record from metadata, or it can be a ghost record or forwarded record. There's so many different categories. Now, but here we are only dealing with record from a table or record from an index for now. So the first 2 bytes going to indicate what type of record it is. It is also going to indicate what is the location of the bitmap. Now, we haven't talked about bitmap, but we are going to do very shortly. Now, the third information going to be there in that status byte is whether this particular record contains any variable length value. Now, a record can contain fixed length values as well as variable length values. So the first status byte but it's also going to tell us whether that's going to contain, this particular record contains any variable length columns. Now the second set of bytes is going to store the total number of fixed length columns in that record. If I have that same example, I have 3 columns. Out of that, 2 of them are fixed length and 1 is variable. Definitely the value stored here is going to be 2 because I have only 2 fixed length columns. So values here stored is going to be 2. Then after that, whatever that that 2 column values, that is going to be stored in the next batch of n bytes. Okay, that's what the third batch. The fourth batch here, the number of columns in null bitmap. Now let's talk about what is a null bitmap is. Now SQL, when a record can store null values, now SQL engine is not going to consider null as a fixed length or variable length. It is going to consider as more like a Boolean value. True or false? Is it null or not, right? What is a null? Is null a value? No, null is not a value. It's a state of value, right? So it's, we always make this mistake saying that, hey, that's a null value. But null is not a value. It's a state of value, unknown value, known or unknown value. All right, anyway. So for SQL engine is going to store a sequence of bits indicating what is the status of null for each column in that record. So let's consider the same example. I have a column, I have a table with 3 columns. If the first column is not null, second column is null, third column is not null, then the bitmap image is going to be 0. So the first 0, 1, 0, because those 2 columns which are not null value is going to get a value of 0. The column with a null value is going to get a 1. So the bitmap is going to be 0, 1, 0. So the fourth batch of bytes is going to tell us the total number of columns in the null bitmap. That is equal to the total number of columns in that record. All right, so it's only going to give you the total number of columns in the null bitmap, but the actual bitmap is stored in fifth batch of bytes. All right, so next n bytes is going to actually store that bitmap, which I explained. So 1 bit per column. That's what I explained like a couple of seconds ago. So the second and third batch of bytes is going to store the variable, the fixed value. The fourth and the fifth batch is going to store the null information in that record, and the next 3 batch of bytes is going to store variable length data. Now talking about variable length data, the first batch, this particular batch is going to store the total number of variable length column in that particular record. If I'm just coming up with another example. So I have a table with 10 columns. Out of that 10 columns, 7 of them are variable length and 3 of them are fixed length. So the value you are going to see here is 7 because that table contains 7 columns which are variable length. Now the most important part of this discussion is this one. If I have 7 variable length values, variable length columns, the next batch is going to contain, or it's going to store, what is going to be the ending position of each of those variable length value. If I have 7 variable length values, so this particular section is going to store 7 endpoints. Each endpoint represents where exactly the variable length value stops. And you also need to understand that each column offset, we call it as offset, okay, column offset. So each column offset is going to be stored in 2 bytes. So if I have 7 column offset value need to be stored, the total number of bytes needed is 7 multiplied by 2, total of 14. Okay, so each column offset need 2 bytes to store. Very, very important. Now, after storing this column offset for each variable length value, then after that, the last batch is going to contain all that variable length value stored in a sequence, which we'll be seeing shortly. We are going to see how to query these data pages directly. So then you will see what I'm talking about. Now I want to concentrate more on this variable length part. So I want to come up with just a very simple example here. So if you look at this example, let me get my pen. Okay, hold on a second. All right. So this is going to indicate that the total number of variable length columns. So in this example, 0 to 0 hexadecimal 0200 indicates that there's going to be two columns. All right. Now, so that is equivalent to this column, right? So this column indicates that there is going to be two columns, which contains variable length data. Now, the next part is going to be the offset, right? So there's going to be two variable length columns. So we need to have two offset numbers. So what is an offset number? The ending position of that data for that particular column. So the first offset is going to be 14. The second offset is going to be 17. So these are the two offset. Now, how much storage needed for this one? So here, this information is stored in 2 bytes, right? Can see that this is 2 bytes, right? So this is also going to be 2 bytes because offset is always going to be stored in 2 bytes. This is also going to be 2 bytes. So metadata of that variable length metadata of variable length column in this particular case need 6 bytes, not the data. This is the metadata of the variable length column. All right. Okay, now after this, the actual from here onwards you will see the actual variable length data. But to retrieve that data, this is going to be catch, because here I said that okay, the 14th byte is going to be the ending location or ending position of the first column, 14th byte. But when I say 14th byte, well, we are not talking about just a 14. It is actually 14 plus all the metadata size. So what is the metadata size here? The metadata size is 2 plus 2 plus 2, 66 plus 14, 20. So the actual endpoint of the first offset is going to be 14 plus 6, 20. So this is, so from here to the 20th position, this is going to be the first column value. What is going to be the now? So that's the first column, first variable length column. How about the 17? 17 is not just a 17. 17 plus that 6 metadata offset, 2 plus 2 plus 2, right? 17 plus 6, 23. So the next column value, variable length column value, starting from here to 23rd byte. All right. So this is how the variable length is actually stored and retrieved. Well, hopefully you understand this. If you have any question, you can certainly put that on the comment section. I'm more than happy to explain it further. Okay. All right. So now the next thing is we need to create a couple of tables, and then hopefully we could able to visualize whatever we discussed so far. I'm going to erase all this, get my cursor back, and going to my SQL Server Management Studio. So I'm going to make a very simple example for you guys. So what I'm going to do is I'm going to create a very simple table consist of 3 columns. Customer ID integer. So integer is a fixed length data, because each integer is going to be we need 4 bytes to store, irrespective of what data stored. It is always going to consume 4 bytes. The second column is going to be customer name. So it's a varchar of 50, so it is a variable length. And customer state is a char of 2, so it's going to consume 2 bytes. It's a fixed length. So only variable length here is the customer data. So let me go and create this. Table is created, and I'm going to insert bunch of records here. So 4 records are inserted, and let's see. So all those records are inserted. Now the first thing is I want to find out, if I want to see how data is stored internally in 8 kilobyte page, or internally stored in data page corresponding to TBL customer. If I just query the table, select start from TBL customer, I'm seeing the data, but that's not what I want. I want to see how information stored inside that 8 kilobyte page for that TBL my customer table. So what we need to do first is we need to turn on a flag called as 3604. So this is going to, if I'm querying data, if I'm going to use the DBCC IND and DBCC page, well, from the SQL Server Management Student, if you want to get more information, if you want to see all this information, you need to turn on the trace. So DBCC trace on 3604, that's what I'm going to execute first. So I could see the output of the remaining two DBCC statements. So that's why I turn on the trace. Now, if I want to find the data pages or 8 kilobyte pages associated with a particular table, then I need to use DBCC IND. That's a DBCC statement. The first parameter is going to be the database. Second parameter is going to be the table. -1 means if there is an index, just include that index information too. So if I execute this, all right, so these are the two 8 kilobyte data pages associated with this particular table. Now here I'm only looking for page type 1. Page type 1 is the data page. So you can see two of them. The page type 1 is actually, that is the IAM file, which we'll be discussing later. So the page file we always want to look for, a page type is always going to be 10. So if you look at here, you can see the page ID is 26336. Okay. So that's what the page ID is. I'm going to copy this and keep it somewhere which we can use. So the page ID of this particular table is 26336. Now, if I want to get more information about, if I want to see what is inside that page, we need to use a DBCC statement called as DBCC page. The first parameter is going to be the database. Second parameter is going to be the file ID. Now, how do I know that the file ID is 1? Well, what we need to do is, if I want to see, so select start from sys dot database files and pointing to AdventureWorks database. All right, so that's going to show us two files associated with AdventureWorks database, one data file and one log file. I mentioned that each data file is having a unique file ID. So the file ID is going to be, we have only one data file here. So obviously the file ID is 1. So we know the file ID. The file ID is going to be 1. File ID is going to be 1, and page ID, we already find out what the page ID is, right? We got the page ID, file ID. So when you use the DBCC statement, the first parameter is going to be the database name. Second parameter is going to be the file ID, which is 1. The third parameter is going to be the page ID, which is 26336. And the third one is what we called as the status, the information, what information you want to display. Well, there is going to be 0, 1, 2, 3. It depends on what value you give, you will be getting different set of information. The 3, the style value 3 is going to give all the information out from that particular 8 kilobyte page. So I am going with 3. Now with this part is an optional component. If you want to display everything in a table format, then you can say with a tabular result, table result. But if you don't want, you can comment that it's an optional component. I'm going to go without that, and later we will include and see what the difference is. So the DBCC page is a command you can use to see how data is stored inside that 8 kilobyte page. And DBCC IND can be used to identify all the data pages associated with a particular table. So you need to use these two to get the result we are looking for. All right, so I executed that DBCC page, and here you go. This is what you stored in that page. All right, so you can see that the page ID is going to be 1:26366, and the total number of slots. We inserted 4 records, right? So there is going to be 4 slots. So this is the page header, by the way. Oh, I forgot to mention that. So this is the page header. The page header contains the page ID. It's also going to contain the total number of slots. Now, let me see. Last log sequence number, and the ghost number of ghost records. Well, there's no, what is a ghost record? Ghost records are records already been officially deleted but still kept in the 8 kilobyte page. SQL engine will later go and clear it out. All right, so I mean there are a couple of other information which we are not really worried about. Now if you come down, all right, so this is a slot 0. So what is a slot 0? Slot 0 is the first record, right? Slot number always start with 0, so slot 0. Now, what is the record type? The record type is it's a primary record. That means it's a actual table record. Now, bitmap. Now, record attribute, whether this particular column contains bitmap, answer is yes. This particular record contains variable column, answer is yes. All right. Record size is going to be 30 in this case. Now, if you look at the memory dump, you will see all the information. Now, let's go back to my insert statement for a second. So what is the information about the first record? First record is customer ID 1, customer name is George Thomas, and New York. So if you look at here, you can see information like New York, George Thomas, etc. Right? So you can see that. But if you really follow this, you can see that, okay, what is going to be slot 0, column 1? All right, what is the value? Customer ID is 1. Slot 0, column 2, customer name is George. And slot 0, column 3, the customer state is New York. Right? So you can go inside each of this, and then you can, and if you scroll down, you are going to see other information as well. Now, if you want to see all this information in a tabular format, now uncomment this with table results, execute. Well, same information, you are seeing it in a more nicer tabular format. Here we go. Okay. All right. So let's do a quick recap here. Now there is a concept called as based on this particular record, what is going to be the size of each record? Well, if you look at this column data type, customer ID is going to be 4, right? Customer name is worker of 50, so I'm going with the maximum size of 50. So 54 bytes plus 2, total of 56 bytes. So apart from this 56 bytes, how many more metadata bytes needed? So if I go back here, so 2 bytes. So we already have 50. How much is that? 50 plus 4, 54 plus 2, 56. Now two bytes for status. So now 56. No, 58, right? Yeah. 50 plus 4, 54 plus 2, 56. Now 2 bytes for the status. Now it is 58. Now 2 bytes to store the total number of fixed length columns. So now it's 60, right? Now this one is going to be, we already calculated that. I'm going to ignore it because that's already part of that 56 we all calculated. Or let's start over again. I mean, we can follow this one. Okay, so let's forget about all those column data type. So 2 bytes here. another 2 byte 4. Now how many fixed column? Well, we have a integer, so it is going to be 2 plus 2 4 plus 2 4 for integer, that's going to be 8. Then 2 for car, that's going to be 6. So I can say, let's do, so here 2 bytes, this is going to be another 2 bytes, this is going to be 4 plus 2 equals 6. All right, so number of that's going to be 2 bytes. Number of bitmap, now the number of bitmap, we have only 3 columns, but it is going to be stored as a 1 byte, so it's going to be another 1 byte here. Now number of variable length column, it's always going to be 2. Here how many variable length columns are there? There's going to be 1, so but still going to be 2 because each column, its offset is going to be 2. And number of variable length column is going to be, the size of the variable length column is going to be 50. So each record in this particular table, it is going to be 2 plus 2 4 plus 6 10 plus 2 12 plus 1 13 15 16 plus 50, a total of 66 bytes. It's extreme case. I mean, if the number of records, number of characters in customer name is less, that's fine. But we are calculating this for the extreme situation, right? So the maximum size of a record in this particular table, the table which we created, TBL customer, is going to be 66 bytes. All right. Now you tell me, can you tell me how many records can be stored in that 8 kilobyte page? Well, the total size is going to be 8. Let's make it as 8,000. Okay, round it to 8,000. So 8,000 divided by 66, right? So let's pick my calculator. So 8,000 divided by 66. So 121. Let's round it to 121, right? 121 records can be stored in each data page corresponding to that particular table. Okay, so this number, the maximum number of record can be stored for a data page for a particular table is what we called as fan out. Okay, FANOUT, that's a fan out. It's the total number of records per page possible for a table is what we called as fan out. All right, so that is all about the internals of a data page. I will also be coming up with another video on GSM, and a lot of other things need to be covered in general. So I'll be using another video for that. For now, this is about the internals. But again, if you like the video, please subscribe my video. If you have any question, you can email me ag.daniel@yahoo.com, or you can call me 267-718-1533. And the best thing is that if you can put a comment under my video, that would be great as well. Okay. All right. Thank you very much for watching this video. You take care, guys. Bye-bye.